Hello, I'm Mark, and welcome to my Unreal Engine tutorials on how to build a simple physics-based movement component for your Unreal Engine games. So in this video series, we will be creating a simple physics-based movement component that you can use in your games to move objects around using Unreal Engine's physics system. I'm going to be breaking this into three parts. So the first part is going to be very code heavy. And it will be creating a base component that we can use which will give us all the systems, access to all the systems we need to be able to move an object like I'm doing right here using physics movement within the game. Part two, we'll then go ahead and move to blueprints, where we'll take that base component and we'll go ahead and implement it so that I can show you how you can then set it up so you can recreate this moving cube and spinning cube. And then in part three, we'll kick it up a notch and move into implementing the networked physics movement so that we can both replicate this movement both at the client and the server. So we've got a lot of code to write today and a lot of ground to cover, so I'm just going to go ahead and minimize this. All right, so let's get started. So first off, I'm going to be using the third-person project. So under Games, when you bring up the Unreal Engine, go to Games, Third Person. We're going to go to C++, Desktop. I'm electing to use Scalable. We don't need starter content. And then once you've got that set up, then just give your project a name, hit create, and then Unreal Engine should go ahead and create a project for you, as well as a Visual Studio project as well, since we will be using C++ to build our component. So once we have the project set up, and we're going to need to add a dependency first so that we can use the physics system. So if you come under your project, and mine's called Physics Movement Live, you should find this build.cs file, and it's a C# file. So here we're going to need to add two more dependencies because we'll be using the physics core module and we'll also be using the chaos module. So I'm just going to copy and paste them right here. So to do that, again, public dependencies, add range, and then you can just go ahead and add these two. So this one should already be set up for you, and we're just going to go ahead and add these two additional modules so that we can create a physics movement system within this project. All right, so once that's done, we now just need to go ahead and start building our component as well as our utilities. To help load up the forces on any object we want to move through the physics system. So to do that, I'm just going to come back to our main project. And I'm going to come up to the content drawer. And in the content drawer, I'm going to come back to C++ classes. And as you can see, I've got the Physics Movement Live folder. And we've already got two classes created. One is the game mode, and the other one is this character. We're not going to do anything with the character for this project, but it's there anyway. So let's go ahead and first off, let's go ahead and create the components. So to do that, I'm just going to right click here and I'm going to say new C++ class. And I'm actually going to be building this component off the pawn movement component that Unreal Engine has. So I'm going to go ahead and so I'm just going to type pawn in the all classes, PAWN, and come down and we'll find the movement component here. I'm going to select that. I'm going to hit next. I'm going to hit public, and I'm going to put it under a subfolder called movement. So that way I can kind of keep things separate. We're going to be building a lot of other components within this project over time. So I'm just going to go ahead and start creating some folder structures right now so we can kind of keep some of these subcomponents packaged together. And then we just need to go ahead and give this component a name. And I'm going to go ahead and call it a physics movement component because that's really what this component is going to be converted into. So everything else looks good. I'm going to go ahead and say create the class. And we'll let it do its thing. Yeah, usually the first class always takes the longest. Compiling. And hopefully we'll have a good compile. Yep, got a good compile. So if I come down to here, I'm going to say reload. And then under reload, we have our public-private structures. And under movement, we now have our new component right there. All right. So we're not going to do anything with this component right now because we're going to need a utilities component that we can use to help load up the forces for us. So we're going to go ahead and build that next. And then we'll come back to this component and then build this out. So we need to build our subcomponent. So to do that, I'm just going to come back to the editor. I'm going to come to classes, under public, under movement, so I have a physics movement. So the next thing I'm going to build is a deferred forces loader. And this is something that I noticed when I was looking. So in order to build this, I was looking at what Unreal Engine had in their chaos wheeled vehicle movement component. And they had a lot of good ideas in there. So I decided to take the loader that they created. It's just a really good way to load up your forces before you execute them, especially when you're starting to deal with really, really complex vehicles which use a lot of forces to move. So that's what we're going to do. So I'm just going to go ahead and say new C++ class. I'm going to come to none. So I'm going to create a structure, and so I'm going to be using none here since Unreal Engine doesn't have a blueprint or a template to create structs out of the box. So I'm going to select none, I'm going to come to next, and I'm going to hit that. And again, this is going to be our deferred forces loader. So I'm just going to come over here. I'm going to just take the core right off. So there's our deferred forces loader. It's public movement folder. So it's going to go into the same folder as our components. And let's go ahead and create that class real quick. And hopefully we'll get a good compile. Yep, all right, cool, good compile. And we're going to reload. All right, so now we've got our deferred forces loader and our physics movement component. Let's go ahead and start defining what this deferred forces loader is. So right now this is a class, but I want it to be a struct. So I'm just going to relabel it struct. And I'm also going to go ahead and just simplify this by just making these constructor and the destructor default, since I'm not going to be doing too much with them. So unlike with a lot of other structures that we've been creating, I'm not going to be putting a generate.h file here. These are actually going to be real C++ structs, and these structs will not be referenced within the editor. These are pretty much going to be within the component as a subsystem of that component. So all right, so that's the base structure. So this is the loader, and within the loader we're going to have some additional structures that we're going to need to create. And before I do that, I'm actually going to also add a namespace and a pre-definition for the rigid body handle internal. So this is actually under the chaos namespace, and we're going to be using this within this loader to be able to load up the forces on our object when we're ready to do so. So again, I'm just going to add this namespace here so that when the compiler compiles, it should be happy. And I'm going to create some other structures, I should say, that we're going to be using. So these are going to be our data structures that we're going to be loading into the deferred forces loader. And then once everything's loaded in, then we'll tell the loader to execute on all those all at once. So I'm just going to copy this structure since it's just a little bit easier for me to go ahead and just copy that. And oh, by the way, I'm just going to go ahead and put the F prefix here since Unreal Engine likes all structures to have a prefix of F, so we'll satisfy that. All right, so this is going to be our add force data, and what we're going to be doing is we're just going to be adding. So this is just our basic force. So we're going to calculate a force, and then this is the force that we want to add. And the reason why I'm going to be using structures is because we're going to be using some complex variables. So we have force and is acceleration change, and we'll get to this when we get back down to the deferred forces. But there's two ways we can apply a force. We can either apply it as an acceleration, in which we'll put the acceleration in and then calculate the force, or we can apply it as a direct force. And I'm just going to go ahead and set this constructor. So since this is two variable struct, I'm just going to go ahead and say the default constructor is just going to be this, and we're going to set that data up. And again, I'm just going to inline this to keep it simple. So we take the force input, and we take this boolean. We set these two data variables right here, and then we will use this when we go and apply it a little bit later on. All right, so that's the first structure that we're going to build. The next one is going to be something a little similar. It's going to be add forces at position. So I'm just going to bring these in here. And it's, again, very similar. This time, instead of it's a force at a position, and so for this we're not going to worry about it's an acceleration change or not. It's just a force and it's at a position. So we can add a force either directly to the focal point, or we can add a force to an object outside of it, which will allow us to create forces that could potentially torque the object while moving, and we'll get to that a little bit later when we start applying this in the blueprint. But for now, so this is the add forces at position data, and that's this struct. And again, we'll go ahead and set up the constructor, so we can just go ahead and create this really easily. I'm just going to bring this over. All right, so again, force input, and it's just we're just setting two vectors, force and position. All right, next, I'm just going to go ahead and copy this. I've got a lot of structures here. I'm just going to minimize this, and I'm going to go ahead and minimize this. So the next structure I'm going to build is the deferred forces. It's actually going to be our torque. So that was deferred forces. So I'm going to change this one to torque. So this is how we're going to rotate an object. So unlike when we do it through character movement, we can't just rotate it. We actually have to add a force to be able to move it and torque it. So, and that's what this is going to do. So for that one, again, very similar to forces. We can torque it, or we can treat this torque variable as an accelerant instead. And again, I'm just going to go ahead and set up the default constructor, make it a lot easier for us. in building this. All right, so that's the torque. And then finally, we've got two more structures. One is going to be impulse, and then one is going to be impulse. The other one will be impulse at position. So when dealing with physics-based systems and physics movement, there's three ways we can move. We can either move through a force, an impulse, or we can then rotate through torquing. Through a torque. So we're just going to cover all of our bases in this system so that we can use it however we want. So that's the impulse, and then impulse again, very similar. And again, the constructor. All right, and then finally, the last one, just like add force at position, we also want to add an impulse at position, which will allow us to then use an impulse if we want to torque an object. So, just going to bring this over. And again, this is just simple little structures that will make our lives a lot easier when having to manage all of these forces later on. So there's impulse, impulse at position, and then finally, let's just go ahead and hook it up. All right, so, okay, so that should be it for all of our force data. So again, we've got force data, which is the raw force, right? So it's going to take an input, and is it an acceleration change? And then we'll just store that data there. At position is a force at the position. Then we've got torque, which is rotating. So this is torque in radians, so all of our torques will be in radians. And is it an acceleration, or is it acceleration change? Or is it an acceleration, or is it just a raw torque value, I should say? And then add impulse data, again, same idea. Impulse, 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 impulse. And then add impulse at position. All right. So now we've got all of our substructures done. Now we can come back to our deferred forces loader, which will take advantage of all of that structured data up there. So within here, I'm going to put a public section and a private section. So, and I'm going to start off with the private section first. So under this private section, I'm going to put a private boolean, which is the is locked, and this will tell me if the way, because we're going to be working between two threads, we're going to have a physics thread and a game thread, and these will be some terminology that I'll be throwing around a lot. So the game thread is kind of what happens in the engine, right, as you're playing on the game. So that would be where your inputs are coming in. It would be anything that's happening on tick. So as you're taking your movement data per frame, then that will get added in. And then what we then need to do is pass that over to the physics thread, which is where the physics stuff gets applied to. And so we're going to need to, and what this object will allow us to do is we'll broker information coming from one thread over to the other thread, so that it can be executed from, taken from the game thread and executed on the physics thread. So that's what we're going to do here. So that's why I've got this is locked. Next, I'm going to go ahead and add some other variables, and these are actually going to be lists of these data structures that were created up here. So yeah, in order to do movement, yeah, especially once you get into more complex vehicles, right, then you're going to be dealing with a lot of forces on that vehicle in order to get the desired movement. And so we're just going to be loading them up into these lists, and then once they're loaded up, then we can then go ahead through each list and then execute each one of those. So that's what we have here. So again, force data, position, torque, impulse data, and impulse of position. So we've just created these little substructures. They've got little bits of information, but we want to keep them together, so using a structure is a great way of doing it. And then we're just going to create lists of those structs, and that's what we have here. And then finally, we're going to have some implementation functions, and this is going to be how we're going to add that information when we execute through these arrays. And so as you can see, I've got force, probably space these out a little bit. So we have add force of position, add torque, and add impulse. And as you can see right now, we've got this rigid handle. And so this handle is the API to the physics thread. This is the physics thread API handle, and that is a pointer reference inside the object so that we can then add these forces so that it can then be applied to the object. So from here, again, we'll be taking in the data, we'll be taking this pointer, and then we'll be then telling it how we want to apply it based on the data in here. So we'll get to that. We'll get to this in just a few minutes, but let's finish defining our object here first. So that's everything under private. So now I'm going to come back up to the public section of our structure. And within here, I'm going to go ahead and just pull all of these functions in all at once since they do the same thing. So first off, we need a way to add forces to these lists. Since this is private, all of this data here is private, we just need to have a function so that we can get access to it and add the value. So again, taking the structure, adding it to it, and adding it into the list. And that's all these do. So we have the applied forces, add, and add. This just keeps it nice and clean. Next, we've got the apply. This is the actual function that when it executes will then tell it to say take all of the forces that have been added into these lists and then go ahead and apply them. And again, this is taking in the rigid handle, and that's why we have this chaos namespace and class up here. And again, this is using the chaos namespace. And then I'm going to also add a reset. So once we've applied the data, we need to be able to clear these out, and that's what this reset's going to eventually do. And then I'm going to add two more functions. One is the unlock, and then this is the isLocked. So what we're going to do, some of the things that I added to this was the ability to lock and unlock it, considering we were going to be working with this system. I wanted this system to be able to work between two threads in a little bit more of a safe manner. So by locking it, it will say I only want to apply all of the forces that I've added in here to the object when I'm ready to apply all of those forces, and so that's what that does. It's kind of like a little safety lock. All right, so now that we've defined our struct, let's go ahead and define our functions here. So let me just pull this up real quick. So I'm just going to go straight down from public into private. So the first thing we're going to do is we're going to come to our apply. And I'm going to go tell it to fix this. I'm going to remove that since we don't need that anymore. Okay, so this is our apply function. So this is what's going to happen on the physics thread when it's ready to apply our forces to our object. So I'm just going to go ahead and just bring it all over first. So what I have here is, first off, we're going to check to see if the thing is locked. Let's color code this a bit. So if it's locked, if it is locked, we're just going to return. Which means we don't want to apply any of these forces in the force loader lists. But when we're ready to apply, we'll unlock it, and then this will then execute. So we'll apply the forces. So apply if we have any applied forces, we'll go ahead and execute that, and then this is our private function, which we'll define in just a minute. We'll also apply any forces at position, apply torques, apply impulses, and apply impulses at position. So again, we're just going to go through everything in those lists, and then once we're done with the lists, we'll then do a reset, and then we'll go ahead and relock, put the lock back in place. All right, so next I'm going to go to reset. So we'll just hover over this, show potential fix. And reset is pretty easy. All we're doing is we're just going into those lists, and we're just going to say empty the lists. So once we're done with all those forces, we just need to make sure that we consume all that force data, and the list is now empty again, ready for us to load them up. So it's just the process is calculate our forces, put them into the loader, right? Tell the loader to execute, and then once it's executed, it will empty out all the force data, and then go back up, and then we'll put in a whole new bunch of force data that we want to execute on the object. All right, and then let's just go. I'm just going to go stub both of these utility functions out real quick. So we have the isLocked and the unlock. So all the unlock does is it just takes the isLocked flag and then just sets it to false. So as we come up to the loader here, right, by default, our loader is always locked. So that means the apply function will not fire until we flip the switch. And that's what we do here. And then after we're done, we flip the switch back. And then, just in case we might want to say, what is the status of the lock? I've just got a little function here to return that status. All right. So that's it for the public side. So let's go into the private side. And so again, this is, as I'm going to be saying, this is where the rubber is going to start hitting the road, as the metaphor says. So let's go ahead and do that. So the first thing is to add forces. So I'm going to say show potential fix. And again, I took a lot of cues from the way that the Chaos Wheel vehicle system was actually adding forces when coming up with this. So it works very similar to what we have here. So in order to add a force, and we have two ways of being able to add this force. So we can either saying that the data is an acceleration or it's a force. So what we're going to do is, first off, whenever we deal with a pointer, because we're using this rigid handle here, we need some utilities, some include utilities. So let's go and add those up here. So that satisfies the argument. So what we're going to be using as far as includes is the physics proxy, single particle physics proxy.h. We're also going to be using the chaos particle utilities.h, as well as the chaos utilities to help manage our physics system. All right, so now that we've got those includes up there now, this is how we're going to be adding forces. So all of the forces get added through this rigid handle. And this, again, this is the API to the physics thread on the object. So first off, whenever, again, dealing with a pointer, we want to make sure that the pointer is valid. Once we know that the pointer is valid, then we're going to check to see, is this an acceleration? If this is an acceleration, then we have to do a calculation. And so in order to find a force from an acceleration, we just take, since this isn't really a force at this point, it's actually an acceleration. We just have to take the acceleration times the mass, and then that will equal the force. So acceleration times mass equals force, and then we just add the force in. And this API takes, two variables. It takes a force, and then we're just going to set the invalidate to true. So it'll use the force and then consume it. And if it is a force, i.e. this is not an acceleration, we're just going to take the data as a force, and we just add it as a force. All right, so that's adding a force. So then we have add force at position. So I'm going to go ahead and fix that. Just going to minimize this. So adding a force at position, I'm going to do something a little different here, because we're saying on this object, we want you to add the force at a point on the object that might not be the center of mass. So again, we're going to make sure that we have a valid pointer. And then what we're going to do, the first thing we need to do is, when dealing with adding a force at a point, is we're going to need to get the center of mass. So Chaos has this utility, which is under the particles utility game thread, which is get center of mass world position. So we pass in the rigid handle here, and this will get us the world center of mass for the object where it is at that position at that point in time. And then in order to then, because we're adding a force at a point that might be outside of the center of mass, right? That force is also going to could potentially create a torque, right? And so if it's going to create a torque, we also need to calculate the torque. So here, what we're going to do is we're just going to take the center of mass minus the position, right, that it is, and that could be position left, position right, or position forward, or position back, or position up, or position down from the center of mass. And then we're going to say, take the force, and we're going to do a cross product on it. So we do a cross product on the position and the force, and then that will give us the world torque. And then what we're going to do is we're just going to say add the force, and then we're just going to add a torque. And again, these are two functions that are sitting right here on the rigid handle. And I can kind of show you, there's a lot of stuff on this handle. So, and some of it you can kind of figure out, where some of it is kind of, well, you might want to play with it. But there's a lot of, this is the API access into the physics thread for the object that we want to move. So I'm just going to push that back. So when adding a force at a position, we're going to add a force and a torque. And this will allow us to move as well as torque around the center of mass. All right, so that's that. So moving on to adding torques. So this is if we just want to add a straight torque. So to do that, very similar to adding a straight force. Again, just color code this. Again, validate the pointer. After we validate the pointer, we're going to check, is this an acceleration change or is it a proper torque? If it's an acceleration change, we're going to need to do a little extra math. So to do that, what we want is get the world's inertia. So to calculate a torque, we need inertia times the acceleration, and then that will equal the torque. Otherwise, if this is a torque, we're just going to take the torque straight in and apply it there. All right, and then finally we have our impulse. So to do that, I'm just going to go ahead and bring this over. All right, again, validate the pointer. Is this a velocity change or an acceleration? If it is, again, velocity change or an accelerator, which is an acceleration. We're going to take the impulse and multiply that by the mass, and that will get us the impulse force, right? And then we're just going to do one extra thing. We're just going to take the linear impulse plus the force, and that's how we'll create our impulse. And then if this is not an acceleration change but an actual true impulse, we'll just go ahead and add it straight in without having to do the extra. So again, this m is this is the actual mass of the object. So when dealing with a skeletal or a static mesh, right, when we make it a physics body, it will take into consideration the material mass, or if you want to override the material mass and set your own mass, it will take that into consideration, and that will then come back, and we can then use that to calculate. All right, so one more, and that's the impulse at position. So I'm just going to go ahead and say fix. And we'll bring this one in. And just like force at position, again, because we're doing an impulse at position, we have the ability to actually move it. So with this one, instead of a torque, we're going to be using an angular impulse instead. So again, here we need the world mass, center of world mass at position. So again, we'll be using these particle utilities. GT is game thread. So this is where it's currently located. The center of mass is currently located in the world space. And then again, do a cross product based on the position and the center of mass and the impulse. That'll get us the angular impulse. And then what we'll do is we want the actual impulse, which is the force down, or the force left, right, up, down, or whatever angle we're putting that impulse in at. And then this is the angular, which will be any kind of, twisting motion that we want to be adding to it as well. All right, so I'm gonna just minimize all this. So that should do it for our deferred forces loader. And so this will be how we're going to be, this should cover all the ways that we're going to want to add forces to an object in order to move it around a map. So I'm going to go ahead and bring up the editor, and I'm just going to do a quick compile to make sure everything looks good. Make sure we don't have any issues. Alright, so everything looks good from the compiler standpoint. So let's go ahead and mosey on back to the physics movement component. I'm just going to go ahead and close this since we don't need this anymore. Alright, so now we're back to the physics movement component. So we stubbed this out earlier, so now, and then we went and created our deferred forces loader. So now let's go ahead and create this component. So first off, we're going to need some includes. So I'm just going to go ahead and include them. So here we are, we have the physics network physics components, and then we also have the deferred forces loader. Why is that a red squiggly? All right, there we go, satisfied. So we have the network physics component, and then we have the deferred forces loader. And we want to make sure that we put these above the generated.h. This should always be the last include in this pile. All right, next I'm going to go ahead and set up the macro up here. This will allow our component to be visible in the editor, so we can add it within the editor to any blueprint. And then next, I'm going to change this. So instead of using generated body, I'm actually going to be using the generated U-class body instead. And I'm going to be doing this because we are going to be overriding various components within the pawn movement component right here. All right, so after that, let's go ahead and stub out our public-private sections. So I'm going to put public there, and this is going to be protected. And I'm also going to add a private section as well for this code base. So this just follows the basic structure that Unreal Engine kind of uses. So public, the first one is usually where if you've got any delegates and constructors, then this is the protected, and then where you'll carry all your protected variables and functions. And then this is public, where I'd probably put all my public functions. And then this is private. This is the stuff which we don't want to be either protected or public. It's private, private, private. And that's where we're going to get started. So first off, I'm going to be bringing in some private variables. So to do that, I'm just going to bring them all in at once. And this is not that. There it is. All right, so first off, we've got our network physics component, and we'll get to this in part 3, but I'm going to go ahead and start building this into the core component right now so that it's there and ready to be used when we get to it in part 3. Then next, we've got again, the rigid handle, and that's our pointer there. So as part of the setup, we'll go ahead and get that handle that we need. And then we also have the body instance, again, another pointer. There's our loader structure. Again, it's private. And then we also have this using network physics prediction. And again, we'll get to this in part 3 when we start setting up for network capability. But I'm going to start baking it in right now, but we'll get to it in part 3. All right, so that's everything that we need for privates. So next I'm going to come back up to protected. All right, so we're not going to do anything with public here. Everything that we need in public is actually going to be handled under the generate U class body here. So we're just going to move straight to protected. So the only variable that I'm going to be adding in this component is going to be our debug messaging. Again, this is allow me to turn on and off debug messaging as we kind of put it into the code. All right, next, virtual override. So next is going to be a series of overrides. All right, so we have begin play, on create physics state, on destroy physics state, and should create physics state. And these are all coming from the movement component that we're inheriting from. So that's why we're kind of inheriting from here. So all of this is set up, and it's set up for movement and navigation, and we're just then going to be adding additional things to this for our physics movement. Then after that, I'm also going to put in my function so that I can display any error messages that I want to display. Then we're going to go ahead and create 2 virtual functions of our own. And we're just going to keep them as empty implementations right now. So the idea is if we want to network this, then what we'll do is we'll inherit this component, and then we will then add additional hooks in for the network piece. The base component will have all the networking there, but in order to use it, we'll need to then inherit. And again, we'll get to this in part 3, where we'll see this in action. But right now, I'm just going to put these virtual functions in as hooks that we can then piggyback off. And then lastly, I've got 3 more utility functions. Since we're going to be dealing with either skeletal or static meshes, I've just got 3 ways for us to get information off it. If it's skeletal specific, we can get it off there. If it's static specific, we can use this function. Otherwise, if it's just mesh, it's something that's both in skeletal and static, we can just use the umesh component. Again, these are just some utility functions that can help us out. And we'll define this once we've finished. We'll get back to the implementation once we've finished with the definition of our class. All right, so that should do it for everything that I want to put under the protected. So let's go ahead and move to the public. So in public, again, we've got two more functions that we're going to be overriding from the parent class, which is our movement component up here. So we have the set update component, as well as this new one, which is probably going to be new to most of you, which is the asynchronous physics tick component. So we won't be using the tick component, we'll be using the async physics tick component instead. It works the same way as the tick component, but this is being called by the physics engine and not by the game. So this is the physics thread, not the game thread that's calling that. All right, so next I'm going to bring in 3 more variables or 3 more functions. So these are just some simple little functions here. Again, is using the network physics prediction. Again, we'll get to this when we get to networking. And then this is the network physics component, which is defined here and being included up there. And then finally, we've got a way to get the body instance. Since these are all private variables, we just need to create some functions to get access to it. And I'm making these public just in case I need public access to it. But again, they're constant, so we can only get them, we can't set them. And then finally, I'm going to add some functions that we can use through the blueprints. And this will allow us to load up forces that we calculate on the game thread in the blueprint so that we can pass it into the loader, and then this loader will then get executed within the async thread here. So that's how we'll be able to broker information between the game thread and the physics thread. All right, so that should do it for the definition. So now let's move to implementation. So first off, I'm going to go ahead and do a potential fix on the begin play. And begin play is pretty easy since I'm not going to be really doing anything with it. I'm just going to go ahead and have it refer back to the begin play on the parent class that it's inheriting from. But what I'm also going to do is, before this, actually, I'm going to put in an include first. I don't want to forget this. We're going to need an include to the single particle physics proxy here again. And then I'm going to add a overridden constructor here. I'm going to put it above begin play. So what we're going to do so since I'm using this generate, right, I'm just going to go ahead and all I need to do is it's going to generate this default constructor for us. So now we just need to define what that is. So first off, in this constructor, we're going to say set is replicated by default to true. And we're also going to take a look to see if network prediction is turned on. And this is a setting that that needs to be set within the game project itself. And again, we'll get to this in part 3 on how you can enable the physics prediction. Once that's turned on, if it's turned on, then we'll also go ahead and create the network physics component. And if it's not, and set it to net address as well as is replicated. So that's what will happen there. But if it's not turned on, then we won't bother with this because we're just using it as a standalone. And we don't need to worry about networking. All right, so I'm just going to minimize begin play. We've got the physics movement component. So next, we have on create physics state. So I'm just going to go ahead and show that. Going to just minimize that as well. So on create physics state, I'm just going to bring all of this over real quick. So again, we're going to refer back to the onCreate physics state, which is in the movement component that we're inheriting from. And then what we're going to do is we're going to add get world. We're also going to go ahead and check to see if is game world. And if it looks good, then we will then go ahead and set the async physics tick enable to true so that we can then start using the async thread. And we'll also update the component. Well, we'll also make, and we'll only want to do this if we have an updated component and an updated perimeter. So there's a bunch of checks that we need to do in order to make sure we can turn this on. And then we have this initialized network physics movement. And again, this is a virtual function which will only be used when we start to use networking. And again, we'll get to that a little bit later. And then and then down here, again, if we're good, then we'll make sure that we'll get the body instance here. So on the create physics state, this is where we'll actually get the body instance from the mesh using the get body instance function right there. All right, so next, on destroy physics state. So I'm just going to go ahead and fix that one real quick. Get us some real estate. And I'll just go ahead and break. So that's on create. So whenever a physics state is being destroyed, we're going to go and tell it what to do. So again, do whatever's on the parent first, and then after that, what we'll then go ahead and say is update the component. If we have an updated components, we'll then say, okay, recreate the physics state. And then if we have a networked physics component, we'll say go ahead and blow out any of the history that we have in that so that we can reset it when we're resetting the physics state. All right, and then as part of the last override in the protected, we have the should create physics state. So this is going to be run to say, should we actually go ahead and create that physics state or not? All right, so here again, we're going to check to make sure that we have we are registered, that the component's registered, and it's not being destroyed. So if that's all good, then we can move down to here. Otherwise, if we're not registered or we're being destroyed, we'll return false. So we shouldn't create the state. And then we'll check to, again, do we have a game world? We also want to see if we actually have a physics scene within that world. So, and then if we have a physics scene, an updated component, and an updated primitive, then we should say, okay, go ahead and create the physics state. And then that should then tell it to go ahead and do that up there. All right, so now we've got all that done. Let's come down to here, and let's go ahead and set up the error message. So again, this is just taking in a string, a color, and how long we want it on the screen. I'm just going to put that there. All right, and that's pretty simple. And again, this will only go out if debugging is turned on. Then, okay, we don't need to do anything with our virtual functions. We're just going to keep them right there. They're just empty for now. We'll be using this when we actually get into networking and more advanced physics movement. But for now, this is the basics. So then under here, we've got these three functions, skeletal, static, and just regular mesh. So let's go ahead and create those. I'm just going to go ahead and fix all three. Hit save. All right, and so again, pretty simple. We have skeletal mesh components. So again, this is going to be get the pawn owner, and then get the root component. So again, the objects that we want are going to be physics objects. They need to be at the root level. So we're going to check the root, check to make sure. So if it's a skeletal mesh, it'll return back a skeletal. If it's a static mesh, it'll be static. And then if it's something that's common between both of them, we can just call this function here, which is again, and all it does is it just casts it. And as long as it's valid, it'll come back with the object. Otherwise, if it's not valid, it'll just return a null pointer. All right, so that should do it for our protected section. So now all we have is the public section to go. So first off, we've got these two overrides. So set up the set updated component. So we'll go ahead and fix that one. Just going to go minimize, minimize, minimize. So there it is right there. And all we're doing is just 2 lines. And so this is on the nav movement component. We're going to say set updated component. So here's the scene, updated component. And then we're also going to go ahead and make sure that we get the owner. So it's either going to be the updated component as the owner, or we'll go ahead and say get the owner of whatever's in here and pass it back. Otherwise, it'll be null. So if we have this, we want the owner, otherwise it'll be null. And then next is the physics tick component. So we're just going to go and open this up. All right, and this is kind of like the beating heart of our component right here. So on each tick, or on each physics tick, delta time, sim time, pretty standard, very similar to how the on tick or the tick component function works. We'll just go ahead and pass it into the super, and then we'll add our own. So first we're going to check to make sure we have a body instance. If we don't have a body instance, i.e. we don't have a valid skeletal or static mesh in the root position of our blueprint, then we're going to go ahead and return. We're not going to try this. Then if we are valid, then what we're going to do is we're going to go ahead and access the body instance, get the actor handle, which is right there. And then off the actor handle, then we're going to call this function, which is the getPhysicsThread API. And that's what we're going to be putting into this rigid handle. And then that's how we're going to be loading up the forces on the object so that we can move it. And then again, we'll do a check to make sure that we have a valid world and we have a valid rigid handle. And if both are valid, we'll then simulate the physics tick. Again, we're not doing anything with this until we get to part 3, but for now, we're just going to put that in there. And then the deferred forces loader. So whatever forces that have been applied to the loader, we're just going to pass the handle in, and then we'll just go ahead and apply them. And we're making sure that we're getting a valid handle with each asynchronous tick here. That way we've got a valid, that way we make sure that the pointer is always valid before we go ahead and try and use it. All right, so that's the asynchronous tick. Next, all right, so those are in line, so we don't need to worry about that. So then we have the get body instance. I'm just going to go ahead and potentially fix that. And I'm just going to go ahead and just add this in here. We could probably just inline that too, but I'm just going to add that there. And then these are some functions. These are the functions that can be called from the blueprint so that we can add the forces in so that we can then apply them within the tick here. So for that, these are just, again, simple, because say show potential fix. And all it is just going to be, so since the deferred forces loader is a structure, we can use the dot concatenator instead of the pointer concatenator. And then all we're just going to do is call the add. And so this add is an overloaded function. So it's using overloading. So based on what we pass in, it will add it, it will call the right function. And so we're just going to say force data, and then this is a struct, this is the constructor, take the force, take whether it's an acceleration change or not, and then create it, and then add it into the list within the loader. And that's all that's going to do. And we're just going to do the same thing for all of these. So I'm just going to go ahead and fix all of these real quick. And so again, force at position, we'll be using force at position. So just make sure that they match. So force at position, force at position. And then the next one is going to be the torque. Just mapping torque. So there we are, torque, torque, torque in radians. Again, all this data is just filtering down, getting stored, ready to be used. And again, add impulse, again, filtering it down, storing it, ready to be used. And then add impulse at position, again, storing it, ready to be used. All right. So then the only other two we've got is that we've got apply force and is applying force. So to do that, I'm just going to fix both of these at the same time. Is applying force. All it's going to do is it's just going to run our unlock. So this will then allow whatever's in the hopper to be drained. And then we have our deferred forces loader, and this is just a check to see if we're locked or not. All right, so that should do it for both the implementation. So this should do it for our base components. So and everything else within this series and the next series, we're going to be building off this component system. But it's set up so that we can use this as is within a blueprint, and we should be able to get some basic physics movement within a blueprint. All right, so I'm going to go ahead, let's go ahead and just make sure this thing compiles first. No, we're not missing anything. Okay, cool, good compile. All right, so I'm going to go ahead and I'm going to go ahead and stop this video. So that will do it for our basic physics movement component. In the next video, part 2, we'll go ahead and take this component and put it into a blueprint so we can recreate our flying cube just using that component as is. So if you like what I'm doing, feel free to like, share, and my videos, as well as subscribe to my channel, and I'll see you again in the next video. Cheers. Bye.